All right, working on part 2 of AA7. Something I didn't mention in the last video because we're not going to run across it in the first 60%, but after 60%, you'll be seeing this a little bit more, making sure that all of your terms and all of in your equation, nothing factors out of all of them. But in this case, nothing does. So if something does, we'll come across that in just a second. I'll show you. It's just like AA5. So looking here, what factors out of the front two? We know what 7 does. 7 and 14 both be divided by 7, so a 7, and then an n squared. So taking out an n squared from here and a 7 leaves you with just an n, and then minus, and then you have 2 right here, because n squared cancel, there's no n's there, and then 14 divided by 7 is 2. And then I'm probably figuring out why I'm putting a minus here. We'll see there's a negative in the middle. In our previous problems, the negative, so like the first two terms, it had been a plus sign in between, and then there was a plus. Minus sign, and then there was a plus. And then over here, there was a minus sign, and then a plus. So there was always, it just followed what it was with. And so in this case, it's going to be a negative, because it just comes down with it. And then what comes out of an 8 and a 16, well, we know what 8 does. But if I pull a negative 8 out of a positive 16, what happens to it? Well, it's just like that little trick I showed you in AA5. Okay? It just turns it into a negative. Well, notice you need these two to match. Well, now they do. So you now have 7n squared minus 8, and then n minus 2. All right, over here, a little bit bigger numbers. Getting rid of 10, so we're pulling a 10 out of these, okay, out of the first two, and then, like I said, nothing else factors out, so 10, and then an x squared, so it's kind of a small 2, 10 and an x squared, so left with a 4x, so x cubed, x squared, left with an x. 4 divided by 10 is 40 divided by 10 is 4, and then 50 divided by 10 is 5. X squared and x squared cancel. And then plus, and then what comes out of the 12 and the 15, hopefully you can see that it is a 3. So if I pull a 3 out, and then I'm left with 4x plus 5. And so now I rewrite my problem. 10x squared plus 3 and 4x plus 5. Okay, just rewriting these two here, and then the 10x squared plus 3 here. All right, now down here, anytime you can always pause and work your problem on your own. Looking at the first two, 8 and 11, the only thing they factor by is 1, so they're not going to change. And so you got to look at the x's. Did the x get pulled out? Of course they do. X squared gets pulled out. All right, so I'm left with 11x. X cubed, x squared leaves you with 1. And then the 8. And then what pulls out of a 44 and a 32? Okay, here's a little hint. If you've already got the front one, you want to make sure the second one matches. Well, look, 11 goes into 44 4 times. 8 goes into 32 4 times. So what's that tell you? It's probably going to pull out a 4, because you want the inside of this parentheses to match the inside of that parentheses. So it makes sense that, kind of give a little hint there. You can use this to figure out this one. So if you're trying to figure out what's the greatest common factor between these two, use what you've already done to solve what you're going to do. And so you get 11x plus 8. Okay, so x squared plus 4 and 11x plus 8. All right, and our last one for this video, we talked about at the very beginning, looking and making sure nothing factors out. This one's going to sneak up on you, so don't let it. Notice that all of the s's have an exponent. Or this one, the back number, and any of the ones we've done so far, we've done 6 problems, none of them have had a variable. Well, this one does. So you know an s can pull out of it. Okay, well, how much of an s? Well, you can pull an s squared out. Okay, so you can pull an s squared out. Now you look and see, is there any number that will divide into or divide all of these by the same number? Okay, well, starting in the back, does 12 and 18 have anything in common? Okay, they both can be divided by 3. So let's check. That would turn into a 4. That would turn into a 6. That means it probably can be used something else, but just to make sure. 3 goes into 30, 3 goes into 45. Okay. So 3, I'm just going to go ahead and cheat a little bit. 3 is the greatest that can be pulled out. So if I pull out 3s squared before I do anything, then that means I'm going to have, just rewriting the problem. Don't rewrite the problem. Rewrite the problem with the 3s squared pulled out. Okay, so 3 goes into 45. How many times? Hopefully you can answer that. Maybe 15. And then you have an s, and then s to the 5th divided by s squared leaves you with s cubed, and then minus. Remember, we're at the whole problem. We're not factoring anything right now. And so 30 divided by 3 gives you 10. And then s to the 4th divided by s squared gives you s squared. And then 18 divided by 3. Remember, all your operations are going to match up, so make sure you minus here, plus here, and then it'll be minus in the back again. 3 goes into 18 how many times? Hopefully you said 6. And then s cubed, s squared leaves you with just an s. And then minus, and then 12 divided by 3 gives you 4. And then s squared and s squared cancel. So that's what it would look like, but now I've got to factor the front 2 and the back 2. So, big S, little s. So, now, what does 15 and 10 have in common? Well, they have an s squared, and then they both can be divided by 5. So, pull out a 5s. And now, I can pull out let me rewrite this real quick. So 15 divided by 5 is 3, and then s cubed divided by s squared is just s, minus, and then 10 divided by 5 is 2, and then s squared cancels. And then now, I'm going to try to pull out another number out of the 4 and the 6. Well, what can 4 and 6 both be divided by? They both be divided by 2, and then that leaves you with 3s minus 2. And so, if you want to rewrite this, you would want to do 3s squared. Remember, that's what we pulled out first. 3s squared. And then the 5s in your first, plus 2. And then whatever's left over. 3s minus 2. All right, looks like a lot of work. Not very difficult. Rewatch it a few times if you need some help.